Special quadrilaterals, day 4, part 2. I'm going to zoom out here. Let us see the next work. Well, since a rhombus is a parallelogram, it inherits it has all the properties of parallelograms. Okay. T, V, W, X is a rhombus. Find each measure. They want the measure of TV and they want the measure of VTZ, this little angle here. Okay, this is too small to be of any use, so I made a bigger copy. Now first they want, let's see, we have W, X, T, and V, and Z is in the middle. Okay, they want TV, but this is a rhombus, so all 4 sides are congruent. We know that because they tell us in the problem that it's a rhombus. If all 4 sides are congruent, that means that 3b plus 4 is equal to 13b minus 9. What's the game? The game is always the same. Get b all by itself on one side, everything else on the other side. I begin by subtracting 3b from each side. 3b minus 3b is 0. 4 is equal to 13b minus 3b is 10b. Now I add 9 to each side. This seems very strange. This may be a little ugly, but what are you going to do? Add 9 to both sides. Four and 9 is 13. 10b. Negative 9 plus 9 is 0. So 10b is 13. b is equal to 13 divided by 10. If that is true, then 3b plus 4 is equal to 3 times 13 over 10 plus 4. 3 times 13 is 39 over 10 is equal to 3.9 plus 4 is equal to 7.9. Am I right? Am I sure I'm right? Let's see. 13b minus 9 is equal to, let's let you see what I'm doing, 13 times 13 divided by 10 minus 9. 13 times 13 is something 169 perhaps. Let's see. 13 times 13, 169 divided by 10 is 16.9 minus 10 is equal to 6.9, so we know we have a mistake somewhere. 3b plus 4, it's back to the drawing board, 3b plus 4 is equal to 13b minus 9. 3b minus 3b is 0, plus 4 is equal to 10 minus 9. Add 9 to each side. 3b plus 4 is 3 times 13, which is 39, divided by 10 is 3.9, plus 4 is 7.9. 13 times 13 is 169 times 10. Well, there is a mistake here somewhere, and since I've checked my arithmetic, maybe there's a mistake in the problem. And I am just going to say that we know our strategy is correct, and I bet if we spent more time we could find it, but we've got to study, we've got other homework, we're going to push on. Now we also have (14a plus 20). Let's look at our problem again. 14a plus 20. What do we know about the perpendiculars of a rhombus? What do we know about the diagonals of a rhombus? They're perpendicular. What does that do for us? Ooh, that does a lot. 14a plus 20 is equal to 90 degrees, because that's the definition of a right angle. I subtract 20 from each side. I have 14a is equal to 70 degrees. Divide both sides by 14, and this gives me something very much nicer. 14 divided by 14 is 1, 70 divided by 14 is 5, a is equal to 5. What does that do for me? Well, I needed to find the measure of VTZ. VTZ is congruent to XTZ. XTZ is 5a minus 5. So VTZ is congruent to XTZ. (5a minus 5). We have found that a is equal to 5. 5a is 5 times 5 minus 5. 25 minus 5 is 20. Angle VTZ is equal to 20 degrees. And we're done with this problem.